up until this point, you've known for graphing points that everything is on an XY Cartesian plane, but that's two-dimensional. So we're going to be looking at three-dimensional Cartesian points and how that's going to change a little bit. Not much has really changed with it. It's just you got to know that there's a third dimension there. When we're looking at three dimensions, it's a little bit different. Normally, in our two-dimensional plane, this is X and Y. But in our three-dimensional, you got to think, outside the box here a little bit. This is X, Y, and then Z. Z is coming up from that plane. When we're talking about this, you're looking at it three-dimensionally. So you might have a point here. But that point is going to have an X point, Y, or X coordinate, Y coordinate, and Z coordinate. And that's just to give it a three-dimensional space. A little bit of vocab here. Just so you're aware, there are different planes, obviously, depending on which dimension you're using. You have an XY plane. Remember, a plane is just a flat surface, kind of like a piece of paper. You have an XZ plane, and then last but not least, you have a YZ plane. So if I was to look at the YZ plane, this would be this dimensional here, just so you're aware. Another point is the origin. The origin's still the same, not that it's really that big of a deal. It just has 3 zeros now. Normally when we're in our Cartesian plane, we have what is known as quadrants. Quad meaning 4. And this, we have octants. First quadrant is, or first octant is going to be positive, 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 which kind of makes sense. Not that I'm too worried about this. So if I were to give you, if I'm looking here at my X, Y, and Z plane, so this is going to be positive, positive, positive. Obviously, if I go down, that's negative. If I'm going this direction on my X, it's going to be negative, and this direction on my Y is going to be negative. Kind of crazy to look at. But if I were to ask you to plot the points, let's go 1, -2, 3. So if I'm looking at this, I'm going to go 1 positive, 2 negative, and then it has to go up, technically in my plane, by 3. Okay, so just looking at that, it's a little bit tricky to look at that three-dimensionally and to plot it, but if you're dealing with certain types of graphs, you will be able to find that. Now, to start off with, we're going to kind of start with the basics. We're going to be looking at distance and midpoint. Distance in a three-dimensional is pretty much the same as distance in a two-dimensional Cartesian plane, except you add in another point. So obviously this right here is, if I correct that, that should be a minus. Obviously I'm taking x minus x and y minus y, but I have a third coordinate now. So that's just z minus z squared. Same thing with the midpoint. The midpoint originally is just x plus x over 2, y plus y over 2. But again, adding a third coordinate, so you just add that on. Not that big of a deal. Just a little bit more calculation. So if I were to have the point -1, 4, and 0, and then I have a point at 2, 5, and 6. So if I'm looking for the distance between this, I'm just using that distance formula and I'm substituting in and working my pattern here. So -1 minus 2 squared plus 4 minus 5 squared plus 0 minus 6 squared. So from here, I'm just doing quick calculations. I get the square root of 46. 46 doesn't have a perfect square that goes into it, so you can leave it that way or you can approximate it. And you would get 6.782. If I'm finding the midpoint, same thing, -1 plus 2 over 2, 4 plus 5 over 2, and 0 plus 6 over 2. Actually calculate that. You'd get a half, 9 over 2, and 3. So really not that bad because it's just like your Cartesian plane if it's two-dimensional. One other thing though, when we're talking about a two-dimensional plane and we have a circle, okay, two-dimensional. Three-dimensional, that circle has now become a sphere. So the sphere is similar to our circle. We have the equation though, x minus h squared plus y minus k squared. Normally we'd have that equal to r squared there in order to get our circle, but again we're going three-dimensional. Plus z minus l. I hate that they use the l, but it is what it is. Equals r squared. So h, k, and l is going to be your center of your sphere. Just like when we had circles, it is opposite of what you see. So if I were to give you, I have a center at -3, 6, 4, with a radius equaling 5. You're just writing your standard equation. Pretty straightforward. X plus 3 squared plus y minus 6 squared plus z minus 4 squared equals 25. Like I said, pretty straightforward. There are other surfaces within besides the sphere. You could also have an actual plane that is three-dimensional. Now this could get a little bit tricky. The plane is written in the equation ax plus by plus cz plus d. D is just a constant equals 0. Oops, sorry. So for instance, let's say that I have 12x plus 15y plus 20z equals 60. Okay. Because it's a first degree equation, aka x, y, and z don't have exponents, it's going to be a plane. So when we're looking at this, we're going to get this equal to 0. Not equal to 0. We're going to get it equal, we're going to divide by that 60. If you notice, everything is divisible by that 60. I now have x over 5 plus y over 4 plus z over 3 equals 1. So here's why this is beneficial. This makes it easier to figure out different coordinates to plot. And I say that because if you think about it, if we have it set equal to 1, if I get this first fraction equal to 1, then these cancel out and have to be 0. Okay, so that's why we want to do it this way. So if I have x equals 5, I already have 1, so that the next two fractions have to be 0, 0. Now I could say the same thing with the y. If I set that y equal to 4, I have it equal to 1. So therefore, x and z are also 0. Same thing again with the z. Well, this makes this a lot easier to plot now. If I'm talking about my Cartesian plane, here's my x, y, and z. Okay, well, I gotta go 5, 0, 0. Okay, that's on my x-axis there. My second point is on my y-axis. And my last one is on my z-axis. Well, that makes that easy. Now I have that plane right there. That wasn't so bad. You just got to get it so that you can figure stuff out and have zeros in there. So that's our three-dimensional Cartesian plane. We'll work with this a little bit more, talking about vectors in space and what to do with those vectors.